Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration by substitution of definite integrals. This is part 18, and I encourage you to check out all the other parts prior to this part, as we are still working on the integration series. Make sure to subscribe so that you don't miss out on any of our future uploads. Getting into today's business, recall from our previous video on indefinite integrals. Integration by substitution is the process of transforming a complex integral into a simplified one, which is the purpose of this channel, Numbers Simplified. Recall from the integration video part 17, the definite integral part 5 as well, we highlighted steps that are crucial and involved in the implementation of the substitution method. Step number 1, we identify a suitable substitution u that simplifies the integral. It is also important to note that the derivative of that substitution has to give us something similar to any other term left out in the integral. Number 2, differentiate the new variable with respect to the old variable and make the dx the subject of the formula. 3, rewrite the integral completely in terms of the new variable u, including the limits, and we are dealing with the definite integrals, so this is going to be crucial for us at this point. 4, integrate the resulting new integral with respect to the new variable. So 5, don't substitute back to the old variables, stick to the new variables. Now let's take a look at an example. Example 1, evaluate giving the exact value of the integral from 2 to 3 of 2x squared divided by x cubed minus 1 dx. The solution. In this case, we can see over here that if we select the denominator as the substitution, once we differentiate that, we are going to get an x squared something, which is going to cancel out with the x squared that we have in the numerator. So substituting for the denominator would be beneficial because it would cancel out with the numerator. So in this case, we let our u be equal to x cubed minus 1. Then our du dx becomes 3x squared. After that, we make the dx the subject of the formula so that we get du over 3x squared. Now, considering the limits, since we are dealing with the definite integrals, so take note, this step is crucial. Otherwise, the answer becomes wrong. So for x is equal to 2, which is the lower limit, this implies that our u will be given by 2. Remember, we are saying that where we have x, we substitute with the 2. So 2 to the power 3 minus 1 would give us a 7. We do the same for the upper limit, which is x is equal to 3. So the u value for that x would be 3 to the power 3 minus 1 is equal to 26. So that will be our new limits. Now substituting for the limits, the dx and the u, we are going to have from our original question, that question will be transformed to the integral from 7 to 26 of 2x squared times u to the power minus 1 du over 3x squared. Take a look at this. The 3x squared has the x squared that will cancel out with the 2x squared. And the u to the power minus 1 came from the x to the power 3 minus 1, which was in the denominator. Now, applying the laws of indices, that is the same as u to the power minus 1. So that's where we got that term from. Simplifying further, we are going to have 2 over 3. Now, that is a constant which we take outside and integrate, keeping the limits and integrating u to the power minus 1. Now take a look at how our problem has been drastically simplified. So with that, we know from our previous videos that involved the natural log, integration with the natural log. That would then mean that we are going to have 2 over 3 times the natural log of the modulus function of u, with the limits from 7 to 26. And I encourage you to check out our videos, part 11 and part 16 of the integration series. We cover such problems in great detail. Now, simplifying further, we would just simply substitute what we have in our limits, starting with the upper limit, of course, subtracting what we would get from the lower limit, so that we have 2 over 3 times natural log of 26 minus natural log of 7. Now, simplifying this further according to the laws and the properties of natural logarithms, we are going to get our final answer as 2 over 3 natural log of 26 over 7. Let's take a look at example 2. Evaluate giving the exact value for the integral from 0 to 1 of 2x cubed plus 2x, all multiplying with the square root of x to the power 4 plus 2x squared plus 3 dx. Now, when we look at this, the solution, we can see that what we have in the square root over here can actually be a wonderful substitution, because once we differentiate that, we are going to get something with x cubed, which is likely to cancel out with the other terms that are left out. So let's make u be the subject, or rather be the choice that we're going to substitute. So we're saying that u is equal to x to the power 4 plus 2x squared plus 3. Then the du dx becomes 4 times x cubed plus x, implying that the dx is going to be du over 4 times x cubed plus x. Now, considering the limits, so we are dealing with the definite integrals, so the limits have to be changed as well. So we're saying that for x is equal to 0, then the u would be 0 to the power 4 plus 2 times 0 squared plus, squared plus 3 is equals to 3 altogether. Nearly got tongue twisted there. And for x is equals to 1, u becomes 1 to the power 4 plus 1 squared plus 3 is equals to 6. Now, substituting for the limits, the dx and u in our original question, we are going to have the integral from 3 to 6, which are our new limits, of 2x cubed plus 2x times the square root of u times du over 4 times x cubed plus 4, which was the derivative that we obtained there. And of course, we can see that we can actually cancel out the x cubed plus x with the one that we have there left. So we factor out the 2, and the 2 over 4 gives us a half, which we have outside there, and the integral from 3 to 6 of u to the half du. And I'm sure we can see where we got the half from. That came from the laws of indices, for we know that the square root of u is the same as having u to the half. Now with that, we are going to have half times 2 over 3 times u to the power 3 over 2 with the limits 3 to 6. Now with that, we are going to have our final answer as 1 over 3 times 6 to the 3 over 2 minus 3 to the 3 over 2. We are keeping our answer as that because we want the exact value. And if we try to simplify this one further, we are going to have values that are not very exact. So we'd rather keep it like that. Let's move on to the next example. Find the exact value of the integral. So we are integrating from 0 to half pi of cos cubed x dx. And in this case, we are given the substitution u is equal to sine of x. So this simplifies our work drastically. Now, with the u is equal to sine x, we can get our du dx as cosine of x from the derivative of the sine x. Now with that, we make the dx be the subject of the formula so that we have du over cosine x. Now considering the limits, we're going to have x is equal to half of pi. Then simplifying that, substituting for x in the new substitution, then we're going to have u being equal to 1. We do the same for x is equal to 0, u is equal to sine 0, which is equal to 0. Now substituting for the limits, the dx and the u, we are also going to consider something here. Recall, if we have cos cubed x, that can actually be expressed as cos x times cos squared x. And with that, we also know that we can actually express cos squared x according to the identity. That can be equivalent to 1 minus sine squared x. Then we substitute back into the integral, meaning that we are going to have the original integral expressed in this format from 0 to half pi cos x times cos squared x dx. And now that can actually be substituted where we had cos squared x. We have 1 minus sine squared x. And in that, we move on to substitute for the values of the u. We also substitute the limits so that we get to integral from 0 to 1 of 1 minus u squared du. With that, now we substitute the limits. We are going to have 1 minus 1 over 3, 1 to the 3, minus 0. So with that, we are going to have our final answer of that original integral to be 2 over 3. So if you have made it thus far into the video, I say congratulations to you. However, I'll leave you with the following task. Find the exact value of the integral from 2 to 3 of 3 divided by x times 2 minus root x dx. Let me know in the comment section how you managed to answer this question or of any problems that you might have encountered. And I'll be glad to also hear of the topics that you may want us to cover in the near future. Thank you so much for watching Numbers Simplified. God loves you.